Hello and welcome. My name is Robin Duke-Woolley. I'm the CEO of Beecham Research, an analyst company in the IoT marketplace. This session is being recorded and it will be available to listen to afterwards. A link will be sent to you afterwards for if you want to listen back to it. Please also remember that you can send a question in any time. We have a discussion for a large part of this session, but there will be a Q&A at the end. So send your questions in and we'll get to those as we progress. I have with me today two speakers. First of all, Stephen Baker, who is Senior Vice President and Chief Product Officer at Core. Slides are not moving. And I have Alistair Fulton, who is COO and VP Ecosystem for Blues. So welcome to you both, Stephen and Alistair.
Nice to see you, Robin.
Evening.
Okay, finally got a slide. So I've been through that now. So if I move on to our introductions. Now, the two speakers here, Stephen and Alistair, are going to say a few words about their companies, and then we'll move on to a short presentation that I'll give to set the scene. And then we're going to go into a discussion of the issues surrounding the complexities of IoT connectivity in the marketplace. So over to you, Stephen, for a couple of words about Core.
Yeah, thank you, Robin. Core has been around in the market for those of you that know, probably more than 2 decades. Starting back in telematics, M2M, and now IoT. We have a global presence built largely and originally for connectivity services throughout the world. However, Core has also grown in its service offerings. So today, Core is a one-stop shop that addresses the full life cycle from asset to cloud for various verticals, and individual components such as connectivity, global connectivity for just about any use case in the world. We have locations all over the world. We have 700 global employees, and probably more integrations with more carriers than anybody in the world or any MVNO in the world. You can go to the next slide.
I've moved it.
We can try to
No,
there we go. Yeah, so as I said, Core kind of grew out of the connectivity world, but today we look at the picture much more broadly. So we realize that all of the IoT solutions that make it to market require a significant effort to build, deploy, manage, and scale those solutions. Each component of that requiring specific capabilities and knowledge and skill sets. And Core has worked very hard over the last 2 decades to combine our knowledge to be able to provide each of those pieces for our customers to help them get to market much more quickly.
Great. And then over to Alistair. And I think the slide will come up shortly. There we go.
Yeah, hi Robin. So yeah, I work for Blues. Blues is a somewhat younger company than Core. We've been around for the last 6 years. We were founded by Ray Ozzie, who previously built a few things like Lotus Notes and Azure and so on. So a real veteran in the industry. And the team is made up of folks like me who've spent, in most instances, 20 years plus in and around IoT, machine-to-machine telematics. Stephen and I know each other well. We go back a long way. And Robin and I think Robin and I spoke to you first when we were first setting out down the path of building what became Azure IoT back in Microsoft. So it's an enduring community, I would say. Blues as a company really exists to do one thing, and that one thing is we help people who make physical products increase their top line revenue, improve their service offering by reimagining those products as intelligent machines that are supported by intelligent services. We see a space where today there are multiple technologies converging and kind of, I'll say, enhancing what we used to call the IoT, but really is more about embedded intelligence these days. Where a lot of machinery was built in the industrial age, it was modestly augmented when we went into the information age. And it's only in recent years that enterprise customers have got very clear on the fact that enhancing their profitability, increasing their competitiveness, and aligning their activities with broader environmental goals of producing more from less requires that they go down this path of firstly connecting everything and then doing something with the data. And we're focused on that first part. We call ourselves a hardware-led SaaS company, which is a bit of a mouthful, but really what that translates into is two products. So we sell a range of edge hardware system on modules that support pretty much every flavor of low bandwidth and medium bandwidth connectivity you would want. So Cat1, LTE-M, LoRaWAN, etc. But those note cards are interchangeable. You can swap one in, swap one out, no code changes, and everything that is radio is hidden behind a single JSON API. But that device functions as a data pump. It doesn't live on the public internet. It makes it a very secure device, and so it needs a proxy in the cloud with which to sync data, and that's a product called Note Hub. So really, note cards send data, Note Hub catches data, and then we route that data to whichever cloud the customer wants it to go into. And if you click to the next slide, Robin.
Yeah, I've clicked.
It's a very genteel pause.
There we go.
So, just to illustrate that a little bit further, this is actually one of our customers' products over on the left-hand side, and one of the high-end industrial refrigeration units that you'll see in large-scale retail outlets. We connect any host microcontroller that you want to use. We regard it as it's not our decision to make, it's our customer's decision to make which microcontroller environment they want to operate in. You can update the code running on that microcontroller using the note card very securely in a fairly unbrickable way. Actually, you actually can't brick note card enabled devices because of the way we manage that update. But we pass data, as I said, from note card to note hub, and then route it through into any cloud that you need. And that's really driven by a belief that when you look at IoT, as I've done for the last few decades, the original problem in IoT was that there weren't tools to do anything with data. And today that's comprehensively not the case. There are multiple platforms, AWS, Azure, Snowflake, hundreds of platforms today that are tailored to meet the needs of customers in virtually any segment of industry. So that's a solved problem. Years ago in IoT, customers didn't really understand what the business case was very often. And I think the maturity of thought in this space has grown very rapidly. And I think every single enterprise customer on the face of this planet, has a view of what they want to do. The thing that they've struggled with, and this is a space that Stephen and I both focused on, the thing they struggle with is just getting stuff connected, which was always meant to be the easy part. We always assumed back in the beginning of Azure IoT that the data would just arrive. And the truth of the matter is that it doesn't. And so that's why Blues has really focused on that tiny little bit. If you want to click to the next slide.
I have clicked already.
Because that enabler is something that goes into every single product. And what we're doing in that connectivity space is essentially making it as simple as possible. So when you buy a note card, it comes with everything that you need to connect on board. It comes with a secure element. It comes with GPS. It comes with an inbuilt antenna. It gives you everything that you need to get a device connected via an M.2 connector. It also comes with connectivity in the case of the cellular card. So the card includes 10 years of connectivity, which means you don't have to have a carrier relationship. Unless you want to, there's a second SIM. You can add your own SIM as well. You don't really have to understand how the underlying radio technology works. As long as you can work in JSON, you operate the note card, and you don't have to make a bet on one connectivity form versus another. You can actually in the field swap cards out as I said, and go from Wi-Fi to Cat1 to LTE to NB-IoT to LoRaWAN without making any any code changes at all. And what that boils down to is just a hell of a lot faster development process. And so on the left, most of our customers, at least in the early days, were customers who tried and tried and tried and failed and tried again and tried. They've been going around in this terrible loop of trying to figure out connectivity, burning dollars in the meantime, and launching prototypes and POCs only to fail yet again. Really what we're trying to do, and I see this time and time again in the way that customers use our product, is drive that time in development down to days. We've had customers build POCs in 2 days and be up and running. Then allow the customer to focus more time on actually figuring out how to get it launched, how to scale the deployment, how to go, to build out through their business. Because like I said, I think we all face an imperative that if companies are not able to connect devices, make them intelligent, and align that economic goal of producing more, with generating less harmful impact, that's an imperative that we all face, and it's essential that companies are able to move down this path smoothly.
Great, thanks very much. Sooner or later, I'm going to. Oh, good. Okay, so after that, I'm going to spend a few minutes just setting the scene, and in particular, I'd like to draw your attention to a report that is available in the handouts. It's quite a large report. It's about 120 odd pages. It's co-sponsored by Core and by Blues, IoT Anywhere, wireless data wherever you need it. And we would recommend that you read it. Now, some of the subsequent slides, the charts that I'm going to show are all from the report, so you'll get an idea of what's in the report. So one of the areas that we're seeing at the moment is incredible growth in IoT worldwide. So there is an increasing need for IoT anywhere in the world, and you can see that the growth rates actually of the southern hemisphere countries is actually much higher than now much higher than the northern hemisphere countries. Obviously, that the northern hemisphere countries tend to be larger markets, but the southern hemisphere, particularly India and South Asia, for example, are really beginning to take off now. So the message from this is that IoT is needed everywhere, and that is great from a market perspective. And we're all very keen to see the market developing quickly globally, but it does raise a lot of difficulties. And the next slide is talking about time to market. In fact, we've got 2 slides here. The first one on the left-hand side is from a survey that we took in very recently, which appears in the report. And the question was, how long does it take you to get your products to market typically? And you can see that the majority is well over 6 months. It's more like a year and a year plus. There is a peak at 6 to 12 months. But the point, I think, has been made by Alistair and will be made later on in the discussion, that really you need to get to market quicker than that. You need to get to market in less than 6 months, because the market is growing quickly. There are lots of competitors out there in the marketplace. If you don't get to market quickly, you're burning the opportunity before you have to start updating and replacing that product with a new one. So the need for speed to market is really, really important. And on the right-hand side is an assessment from the survey that we did of what are the things that take time to get to market. What are the issues that you need to address to get to market? And it's a whole range of things that can get in the way. I'm not going to go into each individual one, because I think that Alistair will be able to give us chapter and verse on each of those when we get to them. But needless to say, it's not just one issue. There's a lot of issues there in getting this stuff to market. and getting it to market quickly. And that's what Blues is primarily set up to achieve, is to get products to market more quickly. And then Core is more set up for dealing with those products when they're in the market um, in a simplified way. So looking at all of the issues that need to be addressed when those products are in the market. So if you like, Blues and Core operate together at different parts of the route to market. Um, and I'm waiting for a slide to change, which isn't changing. There we go. So this is the connectivity usage, and the question that we asked is what types of IoT connectivity are mainly used by your business. And here we see cellular has always been a big use. In some situations, Wi-Fi has also been a big use. More recently, LoRaWAN has been increasing tremendously from where it was before. Satellite, there is a great deal of interest in right now, and we'll probably be getting back to that in the discussion. And then mesh networking also has a very strong part to play in on-site and indeed across-site type of situations. But the point that we're making here is that it's no longer just one connectivity type. When I started in the marketplace, and Alistair and Stephen started in the marketplace, you could have any kind of connectivity you liked, so long as it was 2G. But now things have moved along a bit, and there are lots and lots of variations that are more suitable for different types of applications. And even within cellular, as the next slide shows, I hope. Oh yeah, use of cellular connectivity types with the following data rates for IoT applications. Even within cellular, there are lots of different connectivity bit rates required for different applications. Clearly, the up to 1 megabit per second is the majority, but there are lots of requirements at 1 to 5 megabits, quite a lot of requirements at 5 to 10 megabits, even up to 1 gigabit. So there's a whole range of requirements and the connectivity types that go with that, even within cellular, let alone the other technologies. So there's quite a lot of complexity there. Now, this is a chart that you'll find in the report, and this is just a heat map showing 24 applications down the page and 7 different connectivity attributes across the page. So different applications need different requirements to operate effectively in the marketplace. This is quite deliberately a long range view, because I don't really want you to concentrate in the presentation on the detail, simply to show you, with the fact that all of these things have different weightings, that there are significant differences between different applications in different sectors for different requirements. What does all that mean? Basically, it means that getting the stuff to market and getting the connectivity right is quite a hard thing to do. It was always seen in the past that connectivity would be simple. And as Alistair was saying earlier, it would be in the data, dealing with the data, that would be the complex part. Well, it's actually turned out to be, if anything, the other way around, that dealing with the data is relatively simple. He might dispute this, but we'll come to that. But the actual connectivity part of it is quite hard, because the more that IoT gets into the marketplace, the more different applications we have, all with different requirements, and they're all needed anywhere in the world. So that's a lot of variety and a lot of things that need to be catered for as part of that. So what we're going to do now is to have a discussion about these issues. And when we're going to go through 3 points here. What are the barriers? What are we doing about it? What's next? Then I'm going to cover a few discussion points with Steve and Alistair. and then we're going to throw it open to questions from you in the audience. So you'll get your chance to ask questions. So my first question then is to both Steve and to Alistair, what are the barriers? What are the barriers to getting stuff to market quickly and then being able to connect it correctly once it's in the marketplace? So I don't know who wants to start that. Perhaps Steve, you can start that, and then Alistair can pick that up.
Yeah, I'd be happy to. Thank you, Robin. So I like that last slide. I couldn't read a lot of it because it's very small
No,
print,
no,
but
it's quite intentionally.
but I do like it. In fact, when I looked at it the first time, I thought, you know, there's like 5, maybe 10 more variables you could add to that slide, just
Yes,
on
there are.
connectivity alone. It seems with 4G and now 5G, with things like RedCap, we're getting so many options for connectivity just in cellular alone that selecting the right technology today, that let's say your project is to deploy devices with a lifespan of 5 to 7 years, selecting something today that will last that long, maybe even a decade, which is typically what you try to do in IoT anyway, except for devices that come back and can be remade easily. It's much more difficult. That's one of the biggest barriers that we keep seeing, which technology to use. Another good example of that is just LTE, uh, uh, low power options. So do you use NB-IoT or Cat-M1 if you're going to go global? Well, drawback is it may not be supported globally. And that's with these newer, lower power technologies, coverage can become an issue. I think Alistair with the Blues model, it's a great model to have. I'm sure they run into the situation of having to deal with sovereignty when you go globally. Can the data route out? And I'm sure Alistair's note cards probably have a way to deal with that kind of thing. Um, uh, Another barrier that I can think of right off the top of my mind is once you've kind of selected this technology, putting it all together. It's not as easy necessarily to take a device and put a SIM in it and suddenly it all works. Now the SIMs today are more complicated, but more flexible. So you have multi-IMSIs and you have eSIMs. Does the device, can it handle any time that SIM is switched remotely or locally? Does it know that the APNs change, for example? And then the last piece to the support, the idea of barriers would be how do you build supportability for this end-to-end solution? So you've got an asset, you've got a piece of hardware there, you've got a SIM or some kind of connectivity capability, you've got the data routing up through the cloud, and you have to figure out how to get all of these pieces to interwork over a lengthy period of time, provide support for it, and hopefully everything works for you, you know, out of the box. But I think it goes back to some of your slides on the timing of getting a proof of concept out. It's very difficult to work all of that, debug it, get it to work, and then be able to deploy it and maintain it over that lifespan. So I'll hand it over to Alistair. I'm sure he's got quite a few barriers as well that he can probably bring to bear here.
Yeah, I mean, I think the most obvious barrier is kind of what I touched on earlier, which is, you know, and you did too, Stephen. I mean, we as engineers, we have created a baffling range of choices for customers. And you know, I do think that people have heard me harp on about this before. We bear responsibility for that as an industry. I think we spent a lot of time, myself certainly in the early days, fascinated by all the marvelous things that we could do. And maybe more time, you know, focused on that than we did as an industry, focusing on what customers were actually trying to achieve. And you know, there are some very specific physical constraints when it comes to designing, particularly battery powered sensors. And the majority of things that are not connected today are going to end up being connected either by a sensor that uses a battery or hopefully a sensor that uses a renewable energy source like a printed photovoltaic cell, for example. there are just some issues with physics of designing a solution that is sufficiently low power, and there has been need for new networks to be developed. And I kind of think we've reached a point where there's a toolkit for everything in the box. Let's stop making tools. So I do kind of breathe a sigh of disappointment when I see the next newest radio access technology coming along, when actually customers have already got a tool that serves every purpose. They just can't use the tools because we didn't design them well enough. They're just too hard. The actual barrier I think that creates is not a technical one. I don't think there is a technology issue per se in the IoT space. I think it's a go-to-market issue. And the issue that creates is, if anything runs outside a 12-month cycle, from a return on investment perspective, and from proving a business case perspective, it becomes very difficult for enterprise customers to pull the trigger to invest. It's a typical kind of CFO question. When am I going to get paid back? Don't know. How big is the payback going to be? Well, it's marginal, because in many cases IoT payback is marginal. You save 5% here, 10% there. And in the face of that sort of investment pitch, if you like, most CFOs say, well, I'm going to spend the money on something that is more tangible. I'm going to spend the money on hiring some more procurement people to hammer down the cost that my suppliers charge me. I'm going to, and so the IoT project that's needed to get done has kind of been pushed, gradually down the line. I think what we're doing at Blues and what Core is doing, is a critical way of a critical part of breaking that barrier. By stripping complexity out of the development process, by stripping complexity out of the management process, by just giving customers tools that are easy to use, that don't require them to be, double E's or skilled embedded developers in order to be able to even understand the documentation. We can take away, what is a very significant driver of timeline. As you showed on your other chart, Robin, I mean, when you look at that list of things that drive timeline, it's pretty disappointing, actually, speaking as someone who's been in this space for all of my career. 40% of the time is consumed with POC, pilot, testing, and redesign. That cost alone is enough to sink most business cases for IoT. And that's before you get through to 25% on hardware development, 27% on firmware development, 15% on wireless access design. I mean, these are problems that shouldn't take that amount of time. I mean, there still is the 27% of time that's spent on internal change. And honestly, a lot of the customers I work with, we shorten that development timeline right down, and we work with partners very extensively to really go after that business process piece. Because, enterprise customers, they're implementing IoT solutions often for the direct outcome. I know where my truck is. But just like CRM systems and SAP and ERP systems, they're implementing those solutions because they change the way that they do business. And that's not the job of a company like Blues or with respect to Core. That's a sector specialism. That's someone who works in your market and understands how to help you as an enterprise get better. And so partners play a really critical role in helping businesses understand the potential to adapt, build business case around it and momentum around it, and actually implement it. And that's what stops IoT solutions being this little island that you used to see. It was off over the edge. It didn't touch the main network. It was built on its own separate platform. It was built on it, and they all, whilst we treated IoT as that island, it was never going to be integrated fully into the enterprise, and it was never going to deliver full value. So I think you have to tackle the technical problem, make stuff simple, and then you have to go after the rest of the problem that enterprise customers are trying to solve.
Right, I'm having a little bit of difficulty getting on to the next slide, but the next slide is what are you doing about it? And if the slides don't quite reflect that, there we go. That's what we want. What are we doing about it? So, Stephen, back to you on this one.
Sure, and I'm going to touch a little bit on what Alistair said. So I'd like to tell you that the time frames you showed in your slide were different for us, right? It's not. I think if Alistair brings out a new note card and a new a new a cloud service, if we bring out something new, it does take us that long to get through all of those pieces. But I think what we're doing, and I think Blues does as well, is we're trying to take more of the pieces that take that time that you listed in your slide, and we're pre-building it. We're pre-configuring it, and we're making it work out of the box. So I always felt like as IoT came out of this, dare I say the hype cycle, but as it comes out of this phase, more pieces of it have to operate off the shelf and be targeted. So the idea that there's a generic SIM that works everywhere, God knows we're trying to put that out there ourselves, but it's very difficult to do. But when you look at the entire solution, and I think I can probably say easily that Blues and Core are focused on this, maybe from two slightly different viewpoints. Getting that IoT cloud to work between the asset that's the subject of the Internet of Thing, the thing itself, and the cloud, and simplifying all of that, making it work off the shelf, out of the box, however you want to look at it, is really where I know that both our companies are really focused there. It's saying, hey guys, you don't have to do that timeline. We have a piece that puts you all the way forward, and all you got to do is plug both ends in. And you focus on your business. If I use fleet as an example, from the OBD or the camera all the way to the fleet management application, if we take care of everything in between there, it makes things a lot faster. And so for us to run a business, we create what are basically generic offerings that can be used in multiple use cases that fit that bill. Blues has done a nice job with the hardware, the module, and getting it connected to the cloud. We take that and we wrap, put our connectivity in it, and we wrap all of the services that go around that as ad hoc pieces to the puzzle. The services being all of those things that you need to be able to deploy, all the way from certified to deploy to manage it over the life cycle of the entire product. Things that either a company has to build themselves and source internally, or they can get it from us, very similar to a standard IT service. So IoT services is really kind of what that fits for us. And I don't know, Alistair, I don't want to put words in your mouth, but I think that we're both kind of taking it from that angle. Let's take the IoT piece on ourselves so that our customers can focus on their business and don't have to worry about that. And we're doing it in slightly different takes, but it's really the same concept, I think. So that's what we're doing here at Core, and I think Blues is doing that as well. It's the true simplification, if you will, of IoT.
Yeah, I mean, I think we've done a huge disservice to our customers and ourselves with the whole concept of the Internet of Things. I think even today, we've been banging on about this for 15 years, 20 years. I think if you actually stopped most enterprise customers and said, "What's the Internet of Things?" they would look at you blankly because they still don't understand. They never understood in the first place, and it never really made any sense. And we kind of thought about it again through the lens of engineers of all the fascinating things that we could do. And I hate to say it, but I'll include myself in this too. We revel in complexity. It's a challenge. Customers don't think of what they're trying to do as building an Internet of Things application. They think of it as, how do I know when the refrigeration unit's going to break down so I can actually service my customer's need? How do I find the backhoe that someone stole and took off my building site? How do I know when the trash can is full so that I can send a truck, et cetera, et cetera, et cetera? They're business problems. And so I think one of the first things that we need to do about this is, as you said, Stephen, all of the complexity that's in the box with IoT written on it, let's just deal with that for customers so that they don't have to worry about it. It's not even that they don't care. They don't want to know what's in that box. They have no interest whatsoever. It doesn't deliver any value to them. It is just a means to an end. And so I think as an industry, what we collectively need to do is move away from this concept of the Internet of Things, move away from this idea of separate IoT platforms. And I say that having worked extensively on both Azure IoT and the Hitachi Lumada platform. They were separate platforms to a degree. Azure wasn't intended to start out that way. And we need to just actually get into our customers' boots and understand what it is that they're trying to do on a daily basis. The other thing I think that we need to do about it is move away from this vanity that I think dominated the early days of IoT, where everybody thought they could do everything for everyone. And again, I think you saw that play through in many of the large IoT cloud initiatives that companies like Microsoft and others launched. The goal, lofty goal, and I think well-intended goal, was let's provide a toolkit that covers every eventuality for our customers. When in reality, they didn't want a separate toolkit, they didn't want a separate island, they wanted it just to be part. They had the same expectations in terms of security and manageability and everything else that they had for the cell phones connected to their core infrastructure, for the PCs, laptops, everything else. So I think moving away from thinking of ourselves as a separate industry in our own special little world, it is also something, at a psyche level, kind of we need to do about it. And then, of course, there are practical things that I think the industry is doing, and a lot of that is about cooperation. And it goes back to this point about vanity. Customers don't want to buy everything from a single vendor. They never did. There are companies. There's a long list of companies out there who did a very good job in teaching enterprise customers that buying everything from a single vendor was a really bad idea. And so they don't forget that. And I think in the early days of IoT, everybody was trying to figure out how to make money as providers. I've always said, if there's no point in fighting over the bucket of money in the corner if there's no money in the bucket. And I think a lot of folks in the industry saw one another as competition, when actually what customers saw was a range of different pieces of a jigsaw that were just extremely difficult to put together. And so I think a lot of initiatives, and LoRaWAN has been a really good example of this actually. LoRaWAN is a good technology for what it's designed for. It does the job well enough. If it's easier to use, great, and that's what we spent a lot of time on at Semtech, trying to increase the usability. But the biggest factor of all in LoRaWAN has always been the community. It has lots of friends and lots of people building solutions that leverage LoRaWAN in an interoperable way. I'd extend that same model across, so all of these different connectivity means from a customer's perspective. They just want the data. And it behooves us as an industry to really work together and look for opportunities to cooperate rather than look for reasons that we compete, because we're only defeating ourselves if we continue down that path. Now, I think there are dynamics in the space when you attract lots of VC money, which IoT did for a good long time. Those VCs want a return, they want it quickly, and they see the path to that return by differentiating and coming up with something special and something different. You see the same thing happening in AI today. Lots of money flooding into the space, looking for a quick return. But that sense of cooperation, I think, is something that we as an industry need to do. Aside from all of the engineering stuff and hide it in the box, and like I talked about earlier, making it simple for customers. There's a way of working that the industry needs to adopt. If we're to help our customers be more successful. And if we don't adopt it, we won't see companies deploy the sorts of solutions that we desperately need them to in order to address the drivers of human-caused climate change.
Right. So what's next? Back to Steve.
Well, I'll be a little quick on this one probably. I do think that, first of all, let me qualify with Alistair. Agree with Alistair here quite a bit, because I agree. I think the day that we have to talk about the technologies is quickly diminishing, and it's talking about just bringing the value and really focusing on the end customers' business outcomes. But there are some really great technologies coming out, and I hate to go in technology, but one that I think is going to be instrumental. I don't know about you, Alistair, but I got my first eSIM, I think, 12, 13 years ago from from Rogers of all places. I couldn't activate it and I couldn't download a single thing to it, but I had an eSIM in my hand, so it was awesome, right? But you think about it today, and we're still, I think, struggling a little bit. Now we're with the 2.2 standards, we're starting to get, definitely the consumer MVNOs are taking off like wildfire. You can just download a new eSIM to your iPhone if you need. But I think that's going to finally become what it was always meant to be. So it's going to be interesting to see these multi-MZ eSIM technology are finally going to come to the forefront as far as extreme flexibility throughout the market. So I think that's a really important technology thing. But I think from a business perspective, I think I'll just go back to what Alistair emphasized as well, is that I think it's a lot less about the technology and the fact that it's IoT, and a lot more about getting the data into the applications where they're needed, and maybe a little less need for more standard ways of doing things. If you have the idea of a standard is everyone follows it. Everyone has a common way of doing things. Unfortunately, now we have 17 different standards on cellular alone, and it's getting to be a little too much, right? We can't do all of them. So, seeing that kind of cull out. I mean, I think MB has had its challenges. We'll see if the red cap can make it. But the idea being that we have maybe a few less options that win out in the end, and it kind of consolidates. So I think there'll be some consolidation on coming in the future as far as the technologies and the ways to get to market are.
Okay, that's great. Alistair, do you want to say something about what's next?
Yeah, sure. I'm most excited, I would say, about two things. I think one, the emergence of ubiquitous low bandwidth satellite coverage as a result of technologies like LRFHSS with LoRa, but obviously the ability to send a narrowband signal from a cell phone to a geostationary satellite 38,000 miles above us, I find mind-bending. But it's actually the evolution of those technologies and the packaging of those technologies. We launched a satellite product recently which does the kind of same thing as the cellular business model, 10 years of connectivity in the card, fixed cost, ready to go. But the fact that you are soon to be able to connect a battery-powered device anywhere on the face of this planet, regardless of access to cellular or other terrestrial wireless coverage, I think is really exciting. The other area which I think I'll get fined if I don't say AI at least once, but the kind of the combination of low power edge intelligence and kind of a design model that doesn't really see the difference between the edge and the cloud and kind of melds it all together into an intelligent service. I think that's really interesting. And RISC-V and the low power GPUs you see emerging to run AI or ML applications at the edge to make decisions in the here and now and minimize use of power and bandwidth to transit data back to the core. I think that whole space is really, I worry a lot that AI is massively overhyped and we're going to go through, of course, the disillusionment period. I hope that we go through that faster than we've done it with other technologies like IoT. I see that happening. It's been 6 months ago, everyone was on fire, and now everyone's running around scared. But those two areas, ubiquitous connectivity at low power and low cost, and the ability to act on data in a low power environment at the edge, those are very interesting developments, I think. And again, if we can package those and make them simple for customers so they don't have to actually learn how it works, then we will have, I think, advanced the cause.
Great. I think we'll come back to that actually point in a little while. So just to remind you that if you would like to ask the panel any questions, do please put them in. If you can find the icon for questions, it's a little question mark, at least I think it is, at the top right-hand side of your screen. So if you press that, you might get a tab that you can then enter a question. So if we could start in our discussion points, there are a few that I'd like to ask you. So first of all, what do you think are the most significant connectivity types at the moment and coming up? I think just to give a sort of broad view as to where do you think the main connectivity types are right now? So Stephen, perhaps you could start us off with that.
I think definitely cellular for this industry has been basically the bread and butter, right? I do agree, Laura, it's getting better, although I would say probably more from a private network standpoint rather than a public standpoint. Public is just the business cases don't seem to work very well in that vein. There's some success in Europe, but that one is looking pretty good. And so, and then I think finally the private 5G, 4G, 5G offerings are beginning to and kind of built up, but not a lot came out of it. Now it's actually starting to come back, and I think there's far more offerings out there. They're kitted in a way that you don't have to be a cellular expert to deploy them. So I think that's going to take a little bit more hold in the next coming maybe next 2 years or so.
What do you think of the main connectivity types within cellular? Because as I said in my slide earlier
Mhm.
on, there's a lot of variation of requirements, and I think there is some confusion as to what are actually the main connectivity types within cellular right now.
Well, I think obviously the low power types are thought about or discussed a lot in a lot of the, especially the LTE low power, the Cat 1, the LTM, and the NB. And so those are probably the most, if they're not the most prolific, I think Cat 1 is probably more prolific than the other two at this point.
Right.
5G RedCap, I think it's really going to depend on getting the SA cores out there. Some are built out here in the States and other places, but without SA, you don't have RedCap. So that's going to take a while to get out there. And then again, it's going to be the same challenge with that MB had, which is ubiquity. It's never interesting to deploy technology in one location and go to another, and that technology doesn't exist yet. So I think it's gonna be fun to watch to see how those go. But these low power technologies are very powerful in IoT with the battery power saving modes that they have, as well as the economics. Economics probably from the module perspective as much as from the pure cost of connectivity. I don't think that Cat 1 and LTEM are very far off as far as the cost element goes. So it's really battery savings and power mode and the ubiquity of it are the three things that'll drive that low end.
Right. So, Alistair, could you sort of add to that? Because you see it from a slightly different perspective, what people are developing now, what they're trying to build into their products now. And specifically within cellular, because you might say cellular, within cellular, it's not just cellular. It's like the range of cellular, because that's just getting bigger as we go through time. So Stephen was talking about LTEM and NB-IoT and Cat 1 and RedCap to come. So there's quite a wide diversity there, and it's not any color you like so long as it's GPRS anymore. So
Well, I mean, in IoT, to honestly, in the earlier days, cellular was always the right answer. It was just that the business model was broken and the
yeah.
development model was broken. The
Well, I think
cellular.
I think also it was the applications that people were choosing to
Yeah,
respond to.
but the economics and it was the telco operator's mindset. I worked in O2 for a number of years way back when. It was the mindset that, driven by these exorbitant license fees that they were hit up with, they
Yeah,
had to make the money back some way. And so that, when you looked at machine-to-machine type applications, the economics that the cellular operator needed to apply in order to make some money meant that the business case just was never going to work for most of the applications, where cellular technically would have been the right answer. I think the pat answer to your question of what's the best technology is whatever the hell the customer wants to use, and they shouldn't have to play radio access technology roulette, which you got $500,000 to spend on getting this project to pilot. Which chamber do you want to put it in? Do you want to bet on Cat 1 Biz, Cat M, GSM, LoRaWAN, NBI? Which one? Because it's a bet, and if you shoot your bullet and you hit the wrong target, tough. You better get another bullet. I think a lot of the right answer is whatever the hell you want to use, and that should be an easy technology choice for you to make, and then remake yet again without incurring a huge tariff for having chosen the wrong thing. Most of the enterprise customers I see, they don't know necessarily what environment they're going to be able to deploy their device into. So take the provider of commercial refrigeration units. They don't know what the radio environment's going to be in the retail environment that they go into. And so they quite literally need to be able to change that decision at a moment's notice and say, oh, well, actually, we need to use Cat 1 for this, or we need to use Cat M, or we need to use, and that flexibility should exist. We've just made it extraordinarily hard for people to make those choices for a variety of reasons, some economic, some strategic, some technical, but honestly, the customer doesn't really care about what the problem, why. They just perceive the problem.
Right. Okay. Well, let's move on to another question, which is eSIM. So eSIM is a very popular topic to talk about, certainly within connectivity. And I think that we would all agree that just for cellular, things have moved on from the days when you could use a SIM card, and it's really not very appropriate for a lot of IoT applications. It's still okay for some, but increasingly we're looking for the opportunity for a better form factor of product for something that deals with harsh environments and stuff like that. And eSIM is much more made to measure. But we have iSIM coming up as well. So I think I'd like to get your views on where you see eSIM and iSIM being used. Is it more important in some sectors than other sectors, in some applications rather than others? How do you see it being taken up in the marketplace? So Steve, I don't know if you could give us a view on that.
Well, I think certainly iSIM, integrated SIMs, are going to become very prevalent. And they in themselves can be more or less eSIMs, right? So the idea that the SIM and the device are different entities that have to be combined at some point during production is probably going to begin to slip away. It already has in the consumer world to some extent. It will continue in the IoT world as it makes sense. And I think with it comes some interesting things for the consumer, the IoT consumer, if you will. The IoT consumer has much more control over what they're doing once it's deployed out in the field. The form factors for the devices become smaller because you don't have a SIM slot. And the logistics get simpler because now you're manufacturing and downloading firmware that includes the initial SIM profile or bootstrap. So the whole process of SIM insert, configure, and test really happens during manufacturing, and there's no insert involved. It's soldered on. The profile is downloaded as part of the initial firmware load and tested, and then the amount of flexibility that you get out of that once it's deployed out in the field is what really is intriguing. And it's probably the one area, once you've built the device and deployed it, you've sunk that cost. But with the SIMs, you can make those changes over time and manage your cost over time as well as your coverage over time, making it extremely flexible. So it's a very big leap forward in a number of areas, I think, from between iSIM and eSIM and the evolution of that. And that's why I think the 3.2 is going to be a really good arena for us because it also supports constrained devices. So you get the low end of the market, which is something that we've not been able to do yet. So
Great.
I'll turn it over to you.
Alistair, what have you been finding in the market? Are people really switching on to using eSIM in their designs?
I mean, if you think about it, there's a reason why all the carriers fought against eSIM in the first place, and that's because it gave freedom to customers. And I think that the ability to choose, again, it's choose the best tool for the job at hand without facing a tariff for doing so. eSIM enabled customers to do that, to pick the best carrier in any given instance. I think the progression to iSIM is just a natural one. I mean, it's down that path of miniaturization, like you said, Stephen. And we're in a world now where you can go and buy an 18 nanometer STM32 microcontroller. You know, the process geometries that people are able to work at with GPUs and MCU technology in particular is getting smaller and smaller and smaller, which drives, of course, cost saving in terms of physical cost, but also power saving. And an eSIM model is much more compatible with a microscopic millimeter by millimeter microcontroller than even the hulking eSIM chip that's tiny in and of itself, but it still adds space on the board. And so I think in that relentless drive toward smaller, lower cost, lower power, it's good to see that SIM technology is keeping pace. Where do I see eSIM being used? A lot of it's in the smaller end of things. So a lot of consumer electronics, smartwatches, etc., which is a kind of different world from the one that we're focused on, are making use of those smaller technologies first. But just like everything else, that will flow back upstream into the more industrial and enterprise space that tends to be a little bit more conservative, but that will happen over time too.
Okay, all right. No, that's great. So the next question is really about 2G, 3G sunsetting. So that turned out to be a very difficult situation in the marketplace, and Stephen will be very familiar with that, and Alistair too. Um, all of the issues surrounding sunsetting and moving between generations. I mean, are we going to have the same situation with 4G and 5G and 6G and 7G? And is there
Yes,
are there are there lessons to be learned
stab in
from
the dark.
from the first time round to make it somewhat easier in subsequent generation changes? Because it is really a big disincentive to use cellular if you
Yeah.
have to keep changing things out. Um,
I still find myself counselling customers who have PTSD from when 2G was sunset because they literally, and I think the carrier industry were very, they lacked empathy, for the problem that they
true,
had visited upon
true.
customers. They kind of said, well, of course you knew it was going to get sunset at some point, didn't you? Why didn't you plan on it?
Not that
Which didn't go
we didn't
down
emphasise
well.
it at the time, of course, but
Yeah,
yeah,
it didn't go down well with a lot of customers. Let's say that for sure.
yeah,
I think that in given the reality of sunsetting, which is a reality, networks get sunset, spectrum gets recycled. You know, customers have taken it upon themselves to self-solve the situation, and they've done that by working with providers like Core, by using eSIM technology, by doing what they can to distance themselves from the horror of hardware change, and heaven help them, worse still, hardware redesign. Blues is a slightly different path. You can go open up the box and slot in another card if your network sunsets, and away you go. No code change, no change to API. So I think faced with the reality of sunset, I think customers have self-solved. That said, I do bang my head against the nearest concrete wall whenever I hear cellular operators talk about, 6G is coming and 7G is coming. And it's like, look, sell what's in the box. You're telling customers not to invest in 4G and 5G based solutions. And all that's going to do is delay their choice to implement, because they're going to wait and see, wait and see, wait and see.
yeah,
And guess what? The clock never stops ticking. So you're always going to be waiting and seeing for when the network's going to sunset. Take
yeah.
another path. Avoid yourself that complexity. Work with Core, work with Blues, work with whomsoever, to abstract yourself away from that reality of sunset.
Yeah. So, Stephen, you had a lot of experience of the pain of people moving from 2G to 3G. What would you say are the main lessons to learn from that?
I think, and I know we're running out of time, so I'll be quick, but I'll just say that it seems today like the pace of new technology introduction for cellular is outpacing the business drivers for new technology in cellular. So I think that's what we're seeing a little bit in 5G, the slowness of getting standalone core networks deployed. We're finding out that, well, heck, LTE had plenty of bandwidth necessarily, and some of the more critical high need IoT applications just haven't materialized yet. So I think there's going to be a bit of a reckoning there as far as, hey, how fast are we going to get 6G out, because we really, what are we using it for, right? So
Right.
the business is just not keeping up with the technology updates.
So you think that there'll be a slowdown or a pushback, perhaps?
I'd be surprised not to see that, to be honest with you. It really, it's always driven by the revenue, the incoming business. So we'll better close up here, Robin.
Yes, that's fine. Yeah, okay. So that's the as much as we can fit into this session. So I'd like to thank Stephen and Alistair for your contributions to this. It's a big topic, and actually we could carry on talking about it for ages, particularly as we're all very involved in this. Again, for those watching, I would recommend you download the report, which has, in fact, interviews with both Stephen and Alistair printed in the report, as well as a lot of the charts that you've seen today and many more as well. So with that, thank you for joining us, and look forward to the recording, and see you soon. Bye bye for now.
Thanks, Robin.